Now, one of the problems everyone is complaining about in the charging network side of the business is getting power to the chargers. And the DNO is the one who's designed to get the power to you. So in very simple terms, if you imagine the grid is a bit like a big ring main right round the whole of the UK. And this is very high voltage power, and they just transmit it everywhere. And on the outside of the grid, there are power stations feeding power into the grid, and there are individual houses and solar farms and wind farms feeding it into the grid. So that's the grid, the national grid. When you want to get power locally, you don't go to the grid, you go to the distribution network operator. Now, in this case, it gets a bit confusing because the grid is the distribution network operator. So they do two roles here, and it's called DNEG, Distribution Network Electric Group. And they do the whole lot. And the headquarters for that is Poole in Cornwall. That's midway between Campbell and Redruth near the coast. And that's subject of a separate visit. I went in there and I managed to get a short interview with one of the managers there to find out what's going on. But just because you can't get power here doesn't mean you can't install chargers. So when you come to a site like this is Cornwall Services. So we have a hotel, Holiday Inn Express. We have a services with Costa, McDonald's, everything in there. And petrol station and everything. So there is already considerable amount of power on site. Nowhere near enough to run 6 of these beasts, which are 350 kilowatts. However, we're here today. It's about 11:30 in the morning on a Saturday. There were 2 cars when I arrived. There's nobody here now. So these are not being used continuously. And this is exactly the same as in your house, where you don't use all the power that's coming into your house simultaneously. So at any one time, you've got a 23 kilowatt supply in. The DNO, by the way, corrected that. He said, well, they actually average about 18 kilowatts. Although you've got a 100 amp fuse, that's the maximum output. And most of them operate on about 80 amp fuse, which gives you about 17 or 18 kilowatts of power. But very few houses use that. If you turn the kettle on, it's 3 kilowatts. That's a tiny proportion of 18, 15%. But that's only on for a minute and a half while it boils the water, then it turns off. Your kettle typically, so your iron for doing your laundry, that's typically 2.8 kilowatts, near enough the same as a kettle. And your electric oven, that'll be around about 2 or 3 kilowatts as well. So in a typical house, there's not a lot going on for most of the time. And that simply means that they don't have to provide sufficient power for every house to use 18 kilowatts continuously, all at the same time. And it's the same situation here. So what we have here is, there will be times when someone plugs in here and they'll try and draw 350 kilowatts. Now, I have to say, there's hardly any cars in the country that can take that. There's one, in fact, and that's the Lotus Electra. And that one is supposed to be able to take 350, but on their own website, they say you're only going to get about 240 to 260 kilowatts. That's it, because your battery management system will control how much actually goes in. So currently, in real world, there are no cars in the UK that will pull 350 kilowatts. So these don't need to be 350s. The second thing is, if you only provided 350 kilowatts to the 6 chargers, each would get about 60 kilowatts. And 60 kilowatts is about the power that you would get if you arrive here with, say, a 50% state of charge in a Peugeot 280 or a Hyundai Kona. These have a maximum charging rate of 100 kilowatts, but if you've got a 50%, 40% state of charge in your battery, you're only going to be getting 40, 50, 60 kilowatts out of it. And I've seen that today and the other day when I passed through going west. So these don't need each to be producing 350 kilowatts. Now, you've got a problem here in that they've applied for the power, but it's not yet allowed. Now, there's a number of reasons for that. I went into the National Grid head office in Poole, had a chat with them, And the main reason for delay is apparently not the DNOs. Now, I know they would say that, of course. However, when I talked to him, it does make quite a bit of sense. He said that the grid power to get from the grid down to a substation, all of that equipment is available on a 12-week lead time. So we're talking about 3 months. So from an equipment point of view, they say that most sites can actually be equipped and ready to go within about 3 months. They also said they are very heavily regulated by Ofgem, and they have minimum targets to meet. So those also will set deadlines for them. But what he did say, quite interesting, was that one of the biggest hold-ups is the legal side of it. So for example, here, I don't know where the power is going to come in. There's a substation over there which will feed the services. But if there's another substation, say half a mile over that way, and that's where they want to bring some power in, it would have to come somehow across the motorway, the A30, which is a 4-lane dual carriageway. And so trying to get permission to come across a farmer's field, then underneath the road, then across the services, and they're going to have to dig up stuff to do it. And you end up with a legal nightmare. And I am told, and I'm going to check this, but I'm told that the legal side of it will often take longer than the DNO side of it. The DNO, once they have given you a quote, so to take you through the process, on a site like this, GridServe will do a survey of their own, nothing to do with power. They will have a look here, and they'll have a look at the demand for chargers. And here they've decided that the demand is sufficient for 6. So they got 6 chargers. So they will then go to the DNO, and they will say, we would like to put 6 chargers, each one's 350 kilowatts. Here is the maximum power we want out of it. That will be complicated here because in the background, there's a big field which they've got permission to put a solar PV farm. And that solar PV farm will not only be providing power to the chargers, but it will also be feeding back into the grid. So although 6 chargers might need 4, 5, 6 megawatts, whatever the figure is, if they're producing half their own during daylight hours, and that's going into a battery, which they do have here, then the amount they're drawing off the grid will be severely restricted. So if this needed 5 megawatts, they might say to the grid, well, look, we're going to have this solar farm up and running within 6 months. We will be putting energy back into the grid. So the net amount we want will take 2 megawatts from the solar panels. We've got 1 megawatt of power, a megawatt hour of power in the batteries. So at any one time, we might only need 2 megawatts off the grid. And that the DNO will do all the calculations. They'll work out what they need to get 2 megawatts here. And at that point, they get a quote. And if the company, GridServe in this case, accept the quote, we're in business. So they will put in for this license to actually get the power here. They'll pay whatever they have to pay. And then in the meantime, they can come and do their own thing. And in this situation, and a few other sites I've been to recently, their own thing is really quite interesting because what they've said is, and I'll swing around in a minute, if we put a big battery in, we can actually charge off the services excess power and put that into our batteries when they're not using it. So there'll be a power regulator so they don't take power away from the services, but they will be able to top these batteries up. There will be excess power at certain times of the day to be able to feed into the chargers, and that power goes into their own little distribution network, which is down the bottom. I'll show you that in just a second. So at this point, they can put chargers in and they can feed it off the grid with what they have, and they can also feed it off the batteries. So you've got a combination here. And then when eventually they fit the solar panels there, during the day, particularly in the summer, this is a tourist spot, they will be running these. They could be running 350 kilowatts on all 6 chargers flat out all day, and it will all be coming from the solar farm. So this is really an experimental one, and you'll see signs here. They say we're currently in testing phase for Cornwall Electric Hub, ahead of officially opening the site. The site's not yet open officially, but it is charging. So what they're doing, they're running this and monitoring it, and they're seeing what the load is. Now from that, they may well go back to the DNO and say, well, actual fact, You know, we've ordered 3 megawatts coming in here. Our data shows that we're going to need 2. And that will make it easier and quicker for the DNO to come in and actually supply that. And it is quite possible, at a certain level, that what's available on site would be sufficient for here. It may come down to, they've got a battery over there, but they might have to put a much bigger one in. So they can store overnight, because overnight these don't get used very much. No charger gets used overnight between midnight and 6 o'clock in the morning. They're virtually all deserted. So you've got 6 hours, you can pump energy into the battery, ready for the day, and then when the traffic starts coming down, you can feed out of the battery. Ultimately, you'll feed back into the battery from the grid. And so the site will work. Now, one of the problems is, from a technical point of view, these batteries tend to either charge or discharge. So if you have a situation where everybody plugs into the chargers, then the batteries will discharge to feed them and supplement the grid. If you have nobody charging here and the batteries are a low state of charge, then the batteries will charge. So they're either charging or discharging, and very few batteries, from my understanding, will do a simultaneous charge and discharge. In other words, it can be taking some in from the grid into the batteries, and then the batteries will be releasing only what's needed for here simultaneously. And when I was at Exeter Services, I met up with a company actually doing this, ZPN Energy, and they say they have the first bi-directional battery, so they can put it in, take it out simultaneously. And so this is all changing. This is a massive amount of technology going on. But what it means is this site, although technically not open yet, it is open for business. People are charging here. It is working. They're getting a huge amount of data. And that data will help them build not only this site, but if they can do the same at another site. I was at Ferry Bridge up in the northeast. They have a massive problem there. They're running off diesel generators running on biodiesel. And that's another option. There's another one I'm going to visit next week, and that's up in Scotland. That's on the M74 Kenn services. And they're actually running 6 100 kilowatt chargers off a hydrogen generator. And they get lorry loads of hydrogen coming in, top it up, and then it runs and produces the electricity. These are all stopgap measures that in time will be phased out, we think. Because talking to the manager from the National Grid yesterday, he actually said that in theory, if all of the chargers have their own battery, you can end up with a mini grid within a grid. So you'll have all the chargers' batteries linked, and they'll be fed into the grid as well. And you can effectively run these off solar panels. Hang on a second. Will that reach you a lit? Yeah, it's all right. So you could end up with an actual grid, and Tesla are doing this already in Texas, where they are running half the grid off power generated either from solar panels on houses and factories, gigafactories, and they're also running cars and everything else. So the whole situation is changing. Don't want to go too technical. Just to finish off, I did have a word with the manager in the National Grid, asking him about the future, and he said, it's really not a problem. As long as we have time, we can cope. Their target is 2050. This is for net zero, where they won't be producing any electricity from anything that burns fossil fuels of any sort. So you've got now 26 years. So I said, is that enough? He goes, it's absolutely ample. He said, if all the cars tomorrow suddenly went electric and all plugged in, we would have a fight. But if we've got 26 years, he said, over the next couple of years, you're going to see a lot of movement, a lot of things being developed, because some of these, you're talking about a couple of year lead time on the actual equipment that you need. Some of the transformers only come from Germany, and they're on 18-month lead time. But these are already being ordered, and where they have a department of their own which is looking at the future and what they actually need to do to be able to cope if and when one day everybody has an EV. So it's all going on. The grid seems to be very happy. The DNOs seem to be happy. It is taking far longer than you or I would love it to be. But I don't think most people appreciate the huge transformation that's actually going on with our grid and with the usage. Well, thanks very much for watching. If you have enjoyed this video, please click the like button. And if you'd like to see more, please subscribe and click the notification bell so we can notify you next time we launch a video. And a massive thank you to all our Patreon supporters. It is your support that enables us to go out and make these videos for you. So thank you very much for your contribution. I'm Dave.